Okay. Oh, I went. All right. So a function is going to be an expression, rule, or law that defines a relationship between variables where, and let me get my pen turned on here, where each input or x value has one output. Or y. And so in a function you have input values. It's typically we use the letter x for our input values a lot, and we use y's for output values a lot, but they don't have to be those letters. And those input values are our domain, or we're going to go ahead and put possible x values right here. And range is going to be our possible y values. One of the no, I'm gonna talk about it later. I've got a good application, but it's not on the slide. I need to talk about it yet. Okay. Questions there? You guys remember hearing these words? Sounding familiar, coming back a little bit. Okay, so sometimes they just give us a set of ordered pairs, just like a list of these ordered pairs. So if they give us a set of ordered pairs, domain and range is pretty simple to do. Domain is going to be all your x values. All you need to do is list the x values. You will use a squiggle bracket. I'm sure it has a more official name than that, but I call it the squiggle bracket. So it's -4, -3, 0, 1, and 3. You're just going to list all of the numbers. If one shows up twice, you don't have to list it twice. So like if there were 2 x values that were 3, we would still only list it one time. And then for the range, that's your y values. So you're going to do squiggle bracket, 0, 1, -2, 2, and 3. If it's a like a multiple choice question, they're probably going to put those numbers in order, so they put that -2 first. But you don't have to. You can list them out of order. Okay, so when we're looking at a set of ordered pairs that's given this way, to determine if something is a function, the easiest thing to do is look to see if your x values repeat. Okay, because if your x values repeat, that means there's an x that has 2 different y values, right? 3 goes with 2, and 3 also goes with 7. So if you just ask yourself this question, does, I'm having trouble here. Do the x values repeat? Do the x values repeat? Okay. If an x value repeats, so if your answer to that question is yes, the x value repeats, then that is not a function. And if the answer is no, none of the x values repeat, then that is a function. Okay, so for this particular one, is this a function? Who can tell me?
No.
Why not?
Because it has a 3 and a 3. So like repeating.
Are you talking about like this one right here?
Yeah.
Okay, since those are not both x values, one is an x and one is a y, this is actually okay right here. So you can have a 3, 3 that looks like that. what we're looking for right here is we're looking at only the x values. So if you look at -4, -3, 0, 1, and 3, do any of those numbers repeat?
No.
No, they do not repeat. So is this a function? Yes, it is a function for that. So if the x values do not repeat, then it is a function. Okay, so that is what we're going to do if we have a list of ordered pairs. Then, if we have a graph, there's an even easier way to tell, in my opinion anyway. If you have a graph, we're going to conduct a vertical line test. I gave everybody your vertical line. A vertical line test tells us that if a vertical line touches the graph of a relation only once at each point as it is passed through the graph, the relation is a function, goes in this blank right here. Okay, so if you take your vertical line, you got a graph on the next slide. In fact, let's just go ahead and flip over there. If you take your vertical line and you go across this, let me get my right here, you should not hit the graph more than once. Now, what's happening right here? Our graph touches 2 times, right? We hit right here and right here. We're touching that graph twice, really pretty much everywhere except for that vertex. So that can't be a function, right? Because we touch twice. Now, another thing that we are going to check, and this is new for Math 1 because they do not ask you to learn this in Math 1, is we also can do a horizontal line test. So I've given you state-of-the-art hybrid vertical horizontal line. It will switch from being your vertical line test to a horizontal line test very simply. Make sure you remember vertical is this way, horizontal this way. So for the horizontal line test, you're just pretty much going to do the same thing, and you're going to look to see if it hits twice anywhere. Now, the horizontal line test by itself doesn't matter to you at all, but if there's a function that can pass both the vertical line test and the horizontal line test, then that is a special type of function that we need to know about. It is called a 1-to-1 function. There. And 1-to-1 functions have a lot of properties in mathematics that make them special that we need to know about. So when we're doing problems like this that you see on this slide here, we already said that this does not pass the vertical line test because it hits this graph touches that vertical line at more than one place, right? So example 2 is not a function. Now, if you're, like it's asking you here, supposed to tell if something is a function, 1-to-1 function, or not a function at all, you're done. This is not a function, so it can't be a 1-to-1 function because it's not even a function, right? However, just for fun, would this pass the horizontal line test? So if I did a horizontal line, which I'm not really tall enough to do, but if I did a horizontal line, would it pass?
Yes.
It would, right? It passes the horizontal line test, which tells us some important things when we get to inverses way later, but that's a little higher than we're worried about right now. But if you're asked this question, you don't need to check because it's already not a function. Now, let's look at example 3. Is this a function? Do I pass the vertical line test here? Yeah. Vertical line tests were good, right? So this is a function here. Now I need to decide if I need to add 1-to-1 to that as a 1-to-1 function. Does this pass horizontal line test? Which again, I'm not tall enough to do, but I hear a no, right? Because if you just look at the x-axis right here, I see 1, 2, 3 places where it hits the x-axis. That's a horizontal line. So that cannot be a it's not a 1-to-1 function, but it is a function there. So That's sort of how we'll classify. This next one says to use Desmos, but we're not going to drag out the computers for just that, so I'm just going to graph it up here. Let's see, I was doing something else earlier. So we've got f of x equals, what is it, x squared plus 2? Okay, here we go. Does this pass vertical line test?
Yes.
Yes, it is a function. Is it a 1-to-1 function?
No.
No, it will not pass horizontal line test. It is going to cross. In fact, I can do this. Actually, I can do this without one. Just let me do it. I can do this. There's our horizontal line. Any horizontal line, it's going to touch more than once, except for that vertex. So this one is a function, but it is not a 1-to-1. Now, this last one's tricky. Y equals 3 to the x. Let me type that one in for you. Okay, so this is an exponential function. Here's what we've got. Let's change it. Change color. Orange. Okay, so I can do, anytime you do x equals a number, that is going to be a vertical line, and then Desmos gives you the slider where you can move it right here. Does this one pass a vertical line test?
Yes.
Yes, this is a function. Be careful on exponentials. If you zoom way, way, way out, they start to look vertical like they would not, but they do pass a vertical line test. So exponentials are going to be pass the vertical line test. All right, let's look at, let's do a y equals a number. That's going to give us a horizontal line. Here's this blue line. Does it pass a horizontal line test? Okay, this one's tricky. I said it was tricky. It looks like it should be a big fat no, doesn't it? But watch this. Are these lines actually touching?
No.
They're not. And if I go over here, oh, maybe they touch here. No, they don't. We'll talk more about this later. That graph has what we call a horizontal asymptote. So what's happening is those numbers are getting like closer and closer and closer and closer to 0, but they never actually get there. It's like having 0.1, 0.01, 0.001, 0.00001, right? Just like closer and closer and closer, but doesn't actually get there. So this one is tricky, but it is actually a 1-to-1 function. It passes both. And we'll learn some more about exponentials. They're some of the like ones we can actually apply a lot more places there. All right. So let's move on to some function notation. Function notation is really important to understand because it helps us discuss like algebraic topics at a higher level. There are 2 advantages of function notation that I have listed here. Number 1, it allows for individual function names to avoid confusion as to which function is being examined. Because imagine that we didn't have names in here and I had to like describe each one of you. You know, if you watch The Office, remember the Michael Scott, when Michael Scott names everybody. We won't mention all the names. They're quite inappropriate, but hilarious. But if I tried to describe every one of you, and instead of saying your name, I had to tell something about you to tell which one's part, that would take forever, possibly be offensive. It wouldn't be good for anybody. But you all have names, so that if I need to call him Braden, then I can just say Braden. That's sort of the same thing with function notation. 3x plus 1, if I have y equals 3x plus 1 and y equals 2x minus 7 and y equals x squared plus 4, then I have to call them 3x plus 1 and 2x minus 7. That's the only difference. But I can call them f of x, g of x, h of x, and then I can talk about f and h and g and all of those. So it makes it much easier to talk about. In this class, because we're at a little higher level, we'll be comparing different graphs pretty often. So we need to be really used to function notation so we can, because they'll be named differently. The other thing that it does is it easily identifies the independent variable. And you can tell this because the independent variable is always the one inside of the parentheses. So this is your independent variable. Okay. Sometimes that also could be called your input. Okay. I said I was going to give you like an application of this. How many of you have jobs, work somewhere, and get paid for it? So, I would imagine at your age that pretty much everybody works by the hour. You work so many hours, you get paid this much money. I mean, there are like, I do not get paid hourly. I'm on a salary. But most kids that are working are going to be paid hourly. And some people, I mean, there's some higher paying jobs that get paid hourly too. It just depends. But usually if you're working, part-time jobs, you're going to be paid hourly. That is a function. There is an input and there is an output, and it is a function because there has to be only one output for whatever input you give. So whenever you go and you work for 10 hours and you get paid $10 per hour, you should get paid $100, right? Except for the government takes a lot of your money unless you are working under the table, which you're technically not supposed to do. But that is a function, right? Now, whenever you put in 10 hours, there's not two answers. There's not two Y's that get put out, right? You can't work 10 hours and they might pay you $50 or they might pay you $100, right? I don't think I'd work for somebody like that. That doesn't sound fair. But you put in that input and then there is an output that it gives out. Whenever you think about taxes coming out, it's an even more complicated formula, right? If you just get paid like hourly without taxes coming out, it would be a very simple function. Whenever taxes do come out, that's what they're doing. They, I'm sure somewhere in the office, wherever you're working, whoever's writing the checks puts in how many hours you work. The computer runs it through a formula. It says, oh, you need to pay this much Social Security. You need to pay this much whatever else has to come out. And then you get, the part of the check that you get to take home. So that is an example of like a real life example where there's functions that are working for you at all times. And especially whenever everybody's working different hours, you've got to plug that in, you get an output out. So let's work on evaluating functions. Why is it doing this? It did this first period. It like froze right here where it wouldn't go to the next. Oh, there we go. Okay. So when you're evaluating a function, to evaluate a function, you are going to switch the input for the function's independent variable. A lot of times the independent variable is the x. The x is what you're plugging in for. But it doesn't have to be. We'll see some other examples where they use different letters. One letter that does show up in the real world a lot is a T. Pretty much anything in physics, time is going to be the factor that you're worried about there. Another way of saying this is just to replace the x with the number or expression. So we're going to start out real simple. We've got a pretty simple function here, f of x equals 3x minus 5. They say find f of 4. So the way that you would read this right here is f of 4. Now what it means to find f of 4 is it means plug 4 in for the x. Okay, a lot of times kids read that as like f times 4 because we do use parentheses for multiplication sometimes as well. But if it's in the context of function notation, that's not what it means here. It means plug 4 into the equation. So the way that we're going to do this is we are going to find all of the x's that are in the problem. Sometimes you might want to circle them. It might help you to circle them. And you are going to replace those with 4s. And anywhere you do that, you want to put parentheses around it. If you leave the parentheses off, sometimes it doesn't matter at all. And it works out great anyway. And sometimes it makes the whole problem wrong. So you every time just go ahead and put parentheses. Now, this part right here, f of 4, this is not anything you're going to do any work with. This is just a label that's showing me that you plugged in f of 4. Technically, you could leave it off and you could still get the right answer there, but it's just good math practice here to label it so you're showing whoever is looking at this that you were plugging 4 into the f function. And then you're going to have 3 where we're taking that x out. We're going to put a 4 with some parentheses around it, minus 5. Now, I'm going to let you use the calculator. The calculator can do this, and it'll do it correctly. Sometimes it doesn't do things right, but this is not a hard one to do by hand, right? So let's try it by hand. You can double check it, make sure you got it right in the calculator. Whenever we are evaluating these, we got to do order of operations. Anybody remember what it is? Starts with a P. PEMDAS. Good. And so P is parentheses. E is, let's see, exponents. M is multiplication. D is division. And even though M comes before D right here, those two really kind of go together. You're going to do them in order from left to right there. And A is addition. And S is subtraction. And this kind of works the same way. Addition and subtraction, do those from left to right. They're kind of equals. In this problem, again, we are really only looking at, like, we're trying to simplify this part of it. F of 4 is just there as a label. We're just going to put an equal sign and then we're going to work down. Do we have parentheses? This is like a little bit of a tricky math problem. Yes, technically, of course, there's parentheses there. Is there anything for us to do inside of those parentheses? No, the only thing inside of the parentheses is a 4. So what do those parentheses tell us to do right there? Multiply. It is not actually like parentheses like up here. If there were exponents, we would need to do the exponents before we worried about this particular parentheses right here because it just means to multiply. But there are no exponents either. So we're going to multiply. 3 times 4 is going to give us 12. Oh, what's it doing there? And then we're just going to bring down that minus 5. And 12 minus 5 is going to give us 7. So 7 would be our answer for that problem. Now, I've probably over-explained that problem, but I want it to be very clear, like the process that's going on. So let's do a few more together, and then we're going to do a few on your own to practice. And okay, there we go. I, on purpose, did a few here that give you different letters because I want you to see what it looks like whenever it's not X. But I did make a mistake because I was trying to be fancy. And right here on number 9, that H right there really needs to be a G because otherwise they don't match and you can't answer the question. So you might want to change that to a G right there. Now, in this particular case, I'm finding h of -3, which means I need to plug in -3. What letter am I plugging -3 in for? T. So t is your independent variable this time, not x. But we are just going to take all the t's, every t, and we're going to replace it with the -3. So that will look like this. H of -3. This is just a label. We're not doing anything with it, right? That just tells us, hey, we plugged in -3. And then we're going to do 2, parentheses, -3. The square goes on the outside of the parentheses. Minus 3 times, again, parentheses right here, plus 2. Let me see if I have the... Let me look real quick. I'm going to freeze this real quick. I can work ahead of me on. Okay, this is close enough. Oh my, what's happening here? Now, I know Desmos is better, and we are going to use Desmos most of the time. But let me just show you a couple things on this calculator. It's not perfect like yours. Anybody know the button you hit on these to do an exponent? Where is it at?
Like that little triangle.
Is that a little like sort of triangle without a bottom on it? Just the little caret thing. I call it the to the key because it raises a number to the power. So we're doing -3 to the second. So if you wanted to plug that in, you also have parentheses right there above the 8 and the 9. So it will do it correctly if you type it incorrectly. So 2 times. Also, another thing to watch out for on the yellow calculator. The minus and the negative are not the same. So when you need to do -3, you have to use this negative down here at the bottom. Oh, what's happened? This is, oh, I've still got, that's a problem. It's also doing weird stuff up here that you can't even see because. So if you want to use the calculator, you got to plug in all those parentheses. If you leave them off, sometimes it will give you it will definitely give you the wrong answer. Like if you just do 2 times -3 to the second. What's it doing? Hold on. You'll get the wrong answer. Hello? Good gracious. I'm sorry. Bye. Yeah, bye. She called me twice today because I haven't done my attendance. It's the first day and I'm already falling apart. Okay, where did I even click for that? Everybody's here. I just was showing you that to be really careful. I would do it without the calculator. So if you do it without the calculator, what have you got to do first? Not multiply on this one. What have we got that comes before that? Exponents, which is technically multiplying. We got to do that -3 to the second. That's what kids do wrong on this one first. They multiply first and then they raise it to the second. -3 to the second, what's that going to be? Ethan, what do we get when we do negative 3 to the second? I think I heard it. What'd you say, Emily? 9. Because negative 3 to the second means negative 3 times negative 3. And negative times negative is a positive. So it's going to be positive 9. So this is going to be 2 times positive 9 minus 3 times negative 3 plus 2.
Here's Grinch present.
I'm not back in it today. Is that better? Okay. All right. Then I will multiply, right? So I'll do 2 times 9. I'm going to go up here. Got 18. What do I get here? Positive 9 is good. Plus 2. And then you can add them together really in any order because addition is commutative, but I would do this. I'd do 18 and 2 first, give you 20, add 9. Get 29 for that. I would like for you to try them without the calculator. You can always use the calculator check, but be careful because if you type things in wrong, you're gonna think you're wrong when you're really not. For that. Why is my computer flashing? Okay. All right, let's go to the next one. I'm going to do it without the calculator. You are going to take all those x's. You're going to replace them with 2's. So we're going to have g of 2. That's just a label. We're not doing anything with that. 1 plus 2 over 4 times 2 minus 3. Now, if you type this one into the yellow calculator, you're really going to get it wrong because you have to have extra parentheses on the top and the bottom. In fact, I would do the first step and then you can worry about the calculator because you're going to treat the top and the bottom separately. So it's like there's an extra set of parentheses around the top and an extra set of parentheses around the bottom. So it'll look like this. In the top, we got to do the parentheses first. So we do 1 plus 2, which will give us 3. And on the bottom, we got to do the parentheses first, but there's 3 things there. There's a 4, a 2, and a 3. What should we do first? 4 times 2. So we'll have 8 minus 3. And then we can do 8 minus 3. So we will get 3 over 5. Will that reduce? No, so we're just going to leave that as our answer. You could also get a decimal and do 0.6, but the fraction's fine for that. Okay, 10's got a square root in it. So let's try one of those. I'm going to let you do one on your own. We got R of 5. So that means we're doing plugging in 5 for the P. Right, so that's going to be square root 5 minus 4. Make sure your plus 2's on the outside. It's not underneath the square root. Okay, much like the fraction, a square root's got invisible parentheses right there. You need to do what's inside the square root first. J Ash, what are we going to get inside of that square root? For the 5 minus 4?
Yeah.
Well, we get 1. Yes, I thought you said 4, and that did not sound right. So, so we get square root of 1 plus 2. What is the square root of 1? 1, because square root means what number times itself gives me that number, right? 1 times 1 gives you 1. So we got 1 plus 2, and then that gives us 3. That'll be our answer. Okay, try B on your own. If you're really brave, you can try C on your own, but it's going to be a little different. I'm going to freeze my screen so that I can do it without you guys seeing my work. We'll see how you guys do compared to first period with this one. Yes. What? Okay. All right. what you guys are getting on this one.
That's not
That's
it.
not it. Try it again. You're still working. You can use a calculator if you're. You're still working. You can use a calculator if you need to. If you need to do a square root on the calculator, it's a little bit aggravating. Square root, you're gonna have to hit the blue button and then the X squared button. Can't even unfreeze it. Let me just point to my calculator. If you need us, because if I unfreeze it, you're gonna see my answer.
I got it.
There's a blue button up here in the corner, and then there's an X squared button, like 4 down from it. There's a little blue square root there. So if you need to do a square root on the calculator, you can do it that way. Let's see how we're doing. Not actually seeing the correct answer yet. What's your answer?
It's 4.
I'm not actually seeing the correct answer.
I think I got one right now. It's right.
I've seen one correct answer. Nope. You're doing the opposite of what you need to do there. You're squares instead of square root. Right here. Oh, you want square root, which means like times itself. I'm seeing a few right answers now. Let me put it up here what it should be. You should get 6.
What? I still got it wrong.
Ah. Okay, here's what you do.
Can't you square root 4?
You cannot. You must do what is inside first because there's those invisible parentheses, right? So you cannot square root the 4 until you've already done the 20 minus 4. So you've got 20 minus 4 is what you got to do first. That's going to give you 16, but that's still underneath the square root here. I was seeing some kids like lose that they lost their square root right there. They just said, oh, 20 minus 4 is 16. And then they added the 2. I saw several of you with an 18 as your answer. But the square root is still here. So then to do the square root, you have to ask yourself, what number times itself gives me 16? And 4 times 4 is 16, right? So that is the square root of 16. And then 4 plus 2, of course, gives us 6. We weren't having trouble with that. So we were messing up earlier than those. Okay, questions? Okay. Let's try the last one together. Now, we're not going to get a number answer for this because we're going to do some of it. So if you're like wanting to work ahead, you can, but make sure that you pay attention to this one because it's tricky where it's got a variable. So x squared plus 4. We have to take this and we have to put it right here where the p is at. We're doing the same thing. We're replacing. So we're taking a variable and we're replacing it with another more complicated variable thing there. So this is going to be the square root of parentheses where there was a p. I'm going to put x squared plus 4. And then I just copy the rest of it. So I have a minus 4 that's underneath the square root and a plus 2 right here. Now, here, I can't get like a number answer for this. My answer is not going to be 4 or 7 or 2. But I can simplify it. I can make it a little bit more simple. So we would be starting inside of the square root. And we would be looking for anything we can combine there. Do you guys, what can happen with that plus 4 and the minus 4? Those are going to cancel each other out. That'll be 0 if you add 4 and then subtract 4. So that is going to get us down to the square root of x squared plus 2. And then we got square root of x squared there. And square root of x squared. Square roots and squares are inverses of each other. They undo each other, right? So the square root of x squared is just x plus 2. Now, you can't add x and 2 together because x is a variable, 2 is not. So it is not 2x. What does it mean if you've got 2x? Like if you see 2x written like this? Huh? What's happening between that 2 and the x? What operation? Like, it is, oh, that's good. That is a good word to use right there because that 2 is a coefficient. And 2 is multiplied by x. That's multiplication right there. So x plus 2 is not the same as 2 times x. Right there. But coefficient was a fancy word you pulled out there, Brandon. I'm impressed. Okay. All right, questions? Last one. It's going to be -1. This one's going to be... I'm skipping B for a second. That's the biggest number. What is 95? Okay. And then this one is going to be -4. And the last one is going to be +4. Yep. Normal 4. Okay. So we're going to practice.